Hello, welcome to Meki Teki. Learn as engineer, teach as champion. First of all, I would like to thank my family and my mentor, Professor R. Surendran from Government College of Technology, Coimbatore, and Almighty my God, my friends, followers, my dear students and subscribers. Today, we are going to continue the objective type questions in strength of materials as a part 2. I would like to give the part 1 link in the description box. If you are not watching the part 1, kindly watch part 1 and then come to part 2. And then only you will get a clear understanding about the objective type questions. So here we are going to discuss the first question in part 2 as the shape of the bending moment diagram of a cantilever with uniformly distributed load will be. Let me explain. This is a cantilever beam, so it is a uniformly distributed load. The shear force diagram, which will be 0 at the free end and the maximum at the fixed end, it is in the triangular nature. This is the shear force diagram, and the bending moment diagram will come like a parabolic shape. The bending moment in the negative direction, whereas shear force in positive direction. Therefore, the shape of the bending moment diagram of a cantilever beam with uniformly distributed load will be a parabolic. So, if you can see in a beam, if the shear force is rectangular and bending moment is triangle. If the shear force is triangle and the bending moment is parabola. If you have seen anywhere the shear force is parabola, then the bending moment diagram should be in cubic parabola. Like that, there is a relationship between the shear force diagram and bending moment diagram. For this question, the answer is parabola. And the next question, very superb question. For a simply supported beam of length L, when a concentrated load of W is applied at the center of the beam, the maximum deflection will be. So they are asking about, this is the simply supported beam. There is a point load at this center. So L by 2. So what is the maximum deflection? Maximum deflection at the center of the beam will be WL cube divided by 48 EI. If if it is a UDL, if it is a UDL 5 by 384 W, so this W is capital W, L cube by EI, whereas if it is a small w, 5 small w L power 4 divided by 384 EI, like that it will become. For this question, option D is correct. Next, a superb question. The point of contraflexure is a point where the bending moment changes the sign. The point of contraflexure, which is normally occur on overhanging beam or fixed beams or continuous beams. So these three beams only the point of contraflexure is happening. In that, in the bending moment diagram, if this is the positive bending moment, this is the negative bending moment, so the point where the bending moment changes, so this point is called as a point of contraflexure. The point of contraflexure is also be called as point of inflation or point of virtual hinge. A point of virtual hinge or point of inflation or point of contraflexure, all are same. Please make a note. So this is a very important question, so you can expect these type of questions in any competitive exams as well as in your written exams. So next, A very superb question. The maximum stress produced in a bar of tapering section is that. So consider this is a tapering section. So if the load is acting like this, the maximum stress is produced at the smaller end, because the stress is equal to force by area. Let me consider the force is common in all the taper section. In the larger end, the area is capital A, the smaller end area is the small a. Therefore minimum area in the downward side, therefore maximum stress is being happen. If the relationship is the stress is directly proportional to force, whereas the stress is inversely proportional to area, if the area is reduced, your stress will be more. Like this is the relationship between the stress and the section. The next question is the ultimate tensile stress of the mild steel compared to ultimate compressive stress. For a mild steel, ultimate tensile stress is more than that of the ultimate compressive stress. So more is the correct answer. So ultimate is the maximum stress that can be carried by a material or a mild steel. So very superb question. The energy stored in a body when strained within the elastic limit is known as the strain energy. Correct. If the strain energy stored in a body up to elastic limit, it is called as a resilience. That we are going to discuss later. And next, very superb question. Modular ratio of two material is the ratio of moduli and elasticity. So the modular ratio which is the ratio of moduli and elasticity, m by e. So that is the correct answer. Next, a very superb question. In compression test, the fracture in cast iron specimen would occur along an oblique plane. So we know that the cast iron is a brittle material, so it can take compression load, but it is having a ultimate maximum compression strength. Beyond that, the material will fail in compression too. Therefore, the failure would occur on the plane which is along the oblique plane. Okay, very superb question. A coil is cut into two half. The stiffness of the coil will be, if the coil is cut it out, the stiffness will be get doubled. Let me explain that. We know that uh, force is equal to sorry uh, let, let you explain that the stiffness K is equal to force by deflection. Here we can take it as a load by deflection. We know that deflection is equal to 64 W R cube N divided by C D power 4. If number of coils reduced, the deflection will get reduced. Once the relationship between this stiffness and the deflection is inversely proportional, if the deflection is reduced, then the stiffness will get increased. So if we cut the spring into two half, the deflection will be reduced and the stiffness will be increased by double. Okay, very superb question. The bending stress in a beam is dash section modulus. Bending stress in the beam is dash to the section modulus. Let you explain the bending equation. M by I is equal to sigma by y, which is equal to tau by E by R, I think. Okay, E by R. So don't consider this. So we can take this equation to E by R. Okay, yes. So this is the bending stress sigma, which is equal to sigma by m, which is equal to I by y. Therefore this is called section modulus, say z. Therefore sigma is directly proportional to z, sorry, inversely proportional to z. Okay, how it is coming, m by I is equal to sigma by y. Yes, m by sigma is equal to I by y. So m by sigma is equal to I by y. Therefore I by y is inversely proportional to sigma. Okay, okay, very good, very good, super. So please be careful for this equation. And next, when the shear force at a point is 0, then the bending moment is when the shear force is 0, then the bending moment will be maximum. But there is no reverse case. If the bending moment is 0, there is no other relationship that the shear force should be maximum. Maybe shear force is minimum or not equal to 0 or any case, but in this condition, if the shear force is 0 and the bending moment at the point is maximum. Next question, a superb question. Elasticity of mild steel specimen is defined by. So please don't tick this Hooke's law. We know that the yield point is not correct answer, the proof stress is not correct answer, the plastic flow is doubt, and Hooke's law states that when the material is loaded up to proportional limit, please be clear that up to proportional limit, the Hooke's law defines the proportional limit, whereas plastic flow defines the elasticity of mild steel specimen. So plastic flow defines the elasticity of the mild steel specimen. So next, when a bar is cooled to minus 5 degree fixed with the ends, it will develop. Very good question. So it is fixed, a bar is fixed between ends. If it is cooled, to minus 5 degrees Celsius, if we heat the material, it generally expands. When we cooled the material, it will contract. Therefore the material will try to contract, but the bad luck, the fixed ends will not allow the material to contract. Therefore the tensile stress is created within the material. And the next question is, in order to know whether the column is long or short, we must know whether the column is long or short, we must know the slenderness ratio. The slenderness ratio is very, very important. Based on the slenderness ratio, we subdivide or we classify a column into either a long column or a short column. The slenderness ratio is defined as the effective length to the least radius of gyration. So if it is less than 80, it is called as a short column. If it is more than 80 to 120, it is called as a long column. Like that they define. Please refer. And next, the impact strength of the material is an index of toughness of the material. The impact strength is the index of the toughness of the material. Whenever we test a material with the isotropic, we are using an impact force, and it indicates directly the toughness of the material. And next, very superb question, volumetric strain for a rectangular specimen of length L, breadth B, thickness T, subjected to a pull of P, and it is given by the small e is called strain. So E into 1 minus 2 by m. So 1 by m is called as a Poisson ratio. Either we can call it as a volumetric strain. Del V is equal to overall strain into 1 minus 2 mu. So this is also a correct. So the Poisson ratio is notated like nu or 1 by m. 1 by m. And next, very superb question. When a body is subjected to two equal and opposite pushes, and a result which the body tend to reduce its length. So this is a body, two equal and opposite pushes, so makes the body, the original length is L, let us say, so it reduces by the length of L minus del L. So this is called the stress and strain induced in compressive nature. The stress and strain induced in compressive nature. Two equal and opposite pushes will produce the compressive strain, and reducing length will give a compressive strain. So two equal and opposite pushes gives compressive stress, and the reduction in length will give the compressive strain. And next, modulus of rigidity is defined as the ratio of. The modulus of rigidity is also called as rigidity modulus or shear modulus. So it is defined as the shear stress to the shear strain. Shear stress to the shear strain, which is called as a modulus of rigidity or rigidity modulus or shear modulus or modulus of shear, whatever may be. Okay. And next, so superb question, this is a torsion equation. So torsion equation, very important equation. A mechanical engineer should know the bending moment equation as well as the torsion equation. So torsion equation is T by J is equal to C theta by L is equal to tau by R, and bending equation is M by I is equal to sigma by Y is equal to E by R. So this is the two equations which every mechanical engineer should know. So here the torsion equation, what they called the J by R is known as what? If I by Y is called section modulus, then J by R is called polar modulus. Polar modulus or polar section modulus. So polar modulus or polar section modulus. Please be clear about that. And next, strain resetters are used to. They can ask strain rosets or strain resetters are used to measure the linear strain. The strain rosets or strain resetters are used to measure linear strain. So next question, a very superb question. When a triangular beam is loaded transversely, the maximum compressive stress developed on the bottom layer. At the bottom layer, in an uniform bar supported at one end in the position, the maximum stress under self weight of the bar shall occur at the supported end. So if it is a self weight or we add a weight, the maximum stress is acted upon the fixed support or support end. And next, a very superb question. If both ends of the column is fixed, the effective length. If the both ends of the column is fixed, the effective length is the half of its length. So let you explain. If the column is the both end of the column is fixed, column is hinged, then the LE is equal to L. If the twice of the length comes for one end is fixed and another end is free. One end fixed and another end free means LE is equal to 2 times of L. If it is both ends are fixed, the equivalent length is equal to L by 2, and it is one end is fixed and another end is hinged, then LE is equal to L by root 2. So these are all the four conditions, only available four conditions in the column. Please be careful about this. So both ends are hinged if it is L. If it is one end fixed and another end free, then it is called 2L. When it is both ends are hinged, it is L by 2. If one end is hinged and another end is fixed, and it is called L by root 2. In these four conditions, the weakest column is the one end is fixed and another end is free, and the strongest column is both ends are fixed. So in the both ends are fixed, we can apply more load. It can able to handle more amount of crippling load, whereas the one end is fixed and another end is free, it will take very minimal amount of crippling load. So this is the theory behind this relation. And next, a very superb question: a composite shaft connecting two stepped portions having a spring constant K1 and K2, which is held between two rigid support at the ends. The equal spring constant is like that. It is in series. It is in series. K1 and K2 are in series condition like this. So this is one step. This is another step. So K1, K2 are it is a stepped portion. So it is a series condition. So it is K1 and K2. And next, slenderness of the column is 0 when slenderness of the column is 0 when the length is twice the radius of gyration. If the length is twice the radius of gyration, then the slenderness ratio or slenderness of the column will become 0. And next question, very superb question: resilience is the uh, strain energy per unit volume within the elastic limit. Strain energy per unit volume within the elastic limit, or we can say strain energy stored in a body up to its elastic limit is called resilience. So next question, very superb question, they are asking about the deflection of this spring. So the deflection of the spring, so deflection is W64 WR cube N divided by CD power 4. Here they are giving a capital diameter. So D is the capital diameter. Instead of capital R, we put a D. Then the 64 divided by 8 will becomes 8. So therefore 8 W D cube N divided by CD power 4. And next, yes, a very superb question: a percentage reduction of area in performing tensile test on cast iron may be in the order of 0. So we know that cast iron is a brittle material, so it can able to take the compressive load. It cannot able to take a tensile load. Therefore the tensile test, the cast iron fractures immediately without any reduction in area. And next, very superb question: a material which exhibit the same elastic property in all direction, it is called isotropic. Homogeneous is different. There is no inelastic, there is no isentropic is there for the materials. Only homogeneous and isotropic are available. So isotropic is the correct answer. The homogeneous is the same structure in all direction. That is the homogeneous material, but it exhibits same elastic property in all direction. So that is isotropic. Modulus of rigidity may be defined as shear stress to the shear strain, and the ratio of lateral strain to the linear strain within the elastic limit is called Poisson ratio. So please make a note: the strain divided by strain. Therefore strain doesn't have any unit. So numerator and denominator is no unit. Therefore the final answer should be in the term of no unit term, but Young's modulus, bulk modulus, rigidity modulus all are having an unit of Newton per millimeter square, whereas Poisson ratio is not having the unit. So you can take a Poisson ratio as directly as a correct answer, or the Poisson ratio is defined as lateral strain divided by linear strain. So we can say law Lee for knowing the Poisson ratio. Law Lee is the correct one. Law Lee. Very superb question. So the stress strain diagram is given in below figure. The plastic range occurs. The plastic range occurs beyond A, beyond the point A. So beyond the point A, all are plastic region. So O to A is the elastic range. O to A is the elastic range. Okay, very superb question. The ratio of elongation in a prismatic bar due to its own weight as compared to the similar bar carrying an additional weight of W, which is 1 by 2 is the correct answer. So how it come? No, the deflection, let me consider the deflection is equal. PL by AE is the for the load of external load, and this is called self weight. So it is PL by 2 AE. So 1 is to 2, sorry, a prismatic bar, a prismatic bar, a prismatic bar. 1 is to 2 is the correct answer. Maybe this answer is wrong, I think. If it is a bar carrying a tapering section, if there is a tapering section, so this answer will be correct. So this is the correct answer. So if you have any doubts, please let me know in the comment section, and I will put another video for clarifying your doubts. If you like my video, please do like, share and subscribe my channel, and it will give a greater motivation for making more and more videos in this direction. So I hope you have enjoyed my video. Thank you all. Thank you once again, and Jai Hind.